Okay, so whenever I ask you to compare, even when you were little in grade 4, look at me everyone, no, not even you. I asked you to look at two things and tell me what's the same about them and what is different. So you are putting them side by side and you're checking what's same, what's different, what's on, what's off with the two. If I put Judea and Danica next to each other and I said compare them, what's similar about them? They are both girls. They are both in? Right. They both come to? School. Right. What is different about them? They have different hair, they have different heights, isn't it? They have different sounding voices. They are different ages, they have different personalities. You're going to say that. They have different shoe sizes, thank you. Alright, so now we're going to compare some graphs. You must look for things that are the same and you must look for things that are different, and don't tell me that one bar is taller than the other or one bar is thicker than the other. Right? That's not what I want. I want you to use your maths words to explain. So let's read on page 153. Comparing graphs on the same topic. Graphs that show the same data can look quite different. And some reasons for this are the source of the data can be different. So I want to know how many people like McDonald's. If I did a bar graph for the children sitting here, I'm going to have lots of people, isn't it, Abulele? Right. But if I had to go to a rural village and ask them if they like McDonald's there, they're going to say no. Why? Because they probably haven't had it. Are we together? So the same information, but the bars are going to look very different from each other. So the sources were different. That means where we got our information from was two different places altogether. Then the data was collected from different people and from different places. Also, the data was collected in different contexts. For example, the data was collected at different times of the day. So if I wanted to find out how many cars drive on Hollisley Road, if I go and count in the morning, I'm going to find myself with 3 million cars, isn't it? But if I go out there at 11 o'clock, there's probably going to be 2 cars that go past there. Why? People are dropping off at school, isn't it? And at 11 o'clock, they're all at work. No one's driving around during the day. So the time of the day could be different. And then the data was collected in different ways. So maybe I sent some of you to go and put pamphlets on the door, and the wind blew the pamphlets away, so you're going to get little information. And then I sent another team of you to go and ask them door to door, so they can give you a response immediately. Okay? So the way you collect your data, when you collect your data, where you collect your data can influence the shape of the graph. Okay? Then, example, Sama and Anita are in the same class. For the science project, they measured the temperature. I'm reading in the yellow block. For the science project, they measured the temperature in their classroom each day for 1 week. Lwazi, they drew these graphs to display their data. They each wrote a paragraph summarizing their results. Salma wrote, over a week, the lowest temperature was 16 degrees Celsius, and the temperature rose from 16 to reach a high of 22 degrees Celsius on Wednesday and Thursday. On Friday, the temperature dropped right back down to 16. Anita's paragraph tells us, this week the temperature did not go above 14. Monday was the coldest day with a temperature of 11. Wednesday and Thursday were the hottest. On those days, the temperature rose to a high of 14. By Friday, the temperature dropped again down to 12 degrees Celsius. So, question, why do you think the girls got different results? Let's check. If you compare the graphs, you can see that the pattern for the week was the same. Low, high, higher, same, and then low again. Right? So the pattern is the same. Both graphs show a low on Monday, hotter on Tuesday, hottest on Wednesday and Thursday, and dropping right back down on Friday. However, Salma's graph includes temperatures that are higher than Anita's. The reason is that Salma measured the temperature each day during lunchtime. she went at break time when the sun is right above their heads and we are all sweating outside. Anita, however, measured the temperature as soon as she got to school in the morning when we were all sitting with our jackets on. Are we together? This caused the girls to get very different results because the mornings are cool. And when it gets warmer, then it gets warmer during the day. In other words, each set of data was collected in a different context. One showing the minimum temperatures for each day and the other showing the maximum temperature for each day. Do you understand? Please talk to me, friends.
Yes.
All right. Today's work on page 154. Are you there? Right. These two pie graphs show the percentages. Actually, I'm not going to read it with you. Okay, let me read it, Shin. The two pie graphs show what percentage of a particular day Sammy and Nick spent on different activities. So Sammy did lots of sleeping, but Nick did more sleeping. Can you see that? At least poor Sammy helped his father. Nick, Aiko. Right. There, at least Sammy went to church. Shame. This guy, Nick, is a better way. Even Sammy went to visit Granny. This guy, sleeping, eating, sports. But at least he did his homework. This, oh yeah, Sammy didn't do any homework. Oh, he did a little bit there, blue. So question 1. Besides sleeping and eating, what did Sammy do on that day? List them. Besides sleeping and eating, eh? B. Besides sleeping. Oh, sorry. For A, it's just besides sleeping. For B, besides sleeping, what did Nick do on that day? Write a paragraph summarizing what each graph shows you. Summary. Okay? Small form of what you see. Pick up the most important bits of information to put into your summary. D, suggest one reason why these two graphs show different results. Just one reason. B, number 2, Nikki collected data about the heights of learners in grade 6 and 7 at her school. She drew the graph on the left to show her results. What is the modal height? If I ask for modal height, I'm asking for the? Correct. Who said that? Well done. The most common height of the learners. How many learners are 120 centimeters or shorter? How many learners are taller than 170 centimeters? Write a paragraph summarizing these results. Most common, least common, and what is in that graph. Okay. If you collected the same data at your school, okay, don't do what 2E. Oh, no, do it. Because they're not telling you to draw it. They're telling you if you collected the same data at your school, would your graph look the same? It will not look the same. Why? One main important reason. Mulazi? Yes, there's way less children in our school. Okay. Number 3, compare Nikki's graph with this graph collected by a census at school. How are they similar? How are they different? And why do you think that Nikki got different results compared to this census? All right. Number 4. The graph on the right comes from the national census data. It shows what percentage of households in South Africa has homes with each number of rooms. So, what is the modal number of rooms per house? Approximately what percentage of households live in a home that has 4 rooms or less? That means you're going to have to add different percentages, eh? Okay. What percentage of households live in a room with 8 or more rooms? If you draw this graph for your class, would it have a similar or different pattern to this one? We will collect the data and then you don't have to draw anything. We'll just collect the data and then you can use it to answer that question, okay?
Ma'am?
Yes?
When it says rooms, it means that bedroom, right? Or rooms that counting as a kitchen and a dining room.
A bedrooms. People have 10 rooms in the house? Hey, 10 rooms though. It's a bit excessive.
Yeah. No. Oh, I tell them like 500.
Right, now but we're recording this, people are listening to all our jokes here. Number 5, draw a table to collect data. Oh, okay, so don't do 4D because it's coming up in 5. We will get the data on the board. Draw a bar, sorry sweetheart, draw a bar graph like this one to show your results. Write a paragraph comparing your graph to this one. Give reasons to support the why they are different. Number 6, this pie chart shows that what percentage of families had access to telephones in 2001? Not cellular phones, the landline. Okay, do you know what that is, by the way? Just checking. What percentage of households had a telephone or cell phone at home? What percentage of households had only access to public phones? Do you know what that is?
Yes.
Correct. Or a card. When we were young, we used to put a card in. You load money on the card, then you put the card in the box, and then you.
And then everyone on the street hears what you're talking
No.
about. Oh, yeah.
All the people standing in the queue.
Yes.
And then when you're fighting with your mom.
And then everyone's like,
Okay, but now 6C, guys. Predict how this graph would look different if we collected data today. Give a reason for your answer. It would look very different, eh? Because many of you didn't even know what a call box is.
I know.
And many of you. Or from the movies, right? Okay. Okay, but now do your work, right? Love you. God bless. Bye.